Okay, we're going to do some more trig graphs now. We had introduction in class the other day, so let's have a look first of all at y equals 3 sine x. Mentioned in class that the coefficient of the sine x or the cos x indicates the amplitude. That's the distance between the top of the wave and the middle of the wave, so our amplitude here is going to be 3. As we know, the sine graph starts at 0, 0. We mark in the key points, so it'll max out here at pi on 2, at pi, at 3 pi on 2 and 2 pi. We've got a domain going here between negative 2 pi and 2 pi, so we've got to look at our points on the other side as well. So there'll be a minimum there at negative pi on 2, intercept at negative pi, a maximum up here at neg 3 pi on 2, and back to the axis at neg 2 pi. So starting at the origin, oops, get rid of that. Sorry about this. Let's get rid of that. Oops. That's better. Alright. So starting at the origin, and maximum there, back to the axis, minimum there, and back to 2 pi. And it's better. The other side, oops. On the other side we've got the same sort of situation, minimum through the axis, maximum, and back to there. So let's fix that up. There's our graph of y equals 3 sine x. Standard graph, period of 2 pi, and a maximum at 3 and minimum at neg 3 because the amplitude is 3. Next graph I'd like to look at is y equals sine 1/2 x. Saw the other day that we had a formula for period of trig graphs, and period equals 2 pi on n, where n is the coefficient of the x to the right of the sine or the cosine. Okay, so here we have 2 pi over a half. So there we go, and so that means our period equals 4 pi. So period equals 4 pi, like so. So that means one full wave will last for, on the x-axis, for 4 pi. So our key points, oh, by the way, there's no number in front of the sine, therefore the amplitude of this graph is 1. Okay, so we're going to have a maximum here at pi. It's going to pass through the axis at 2 pi. It's going to be a minimum here at 3 pi, negative 1, and here got the graph finishing at 4 pi. Actually, I'm going to change this question because I'd like to, it's going to be a bit cramped, so let's just change this question. I'm going to leave it at a half, y equals sine 1/2 pi, but let's change it to y equals 3 sine 1/2 x. Sorry, not pi. So let's change it to that. That gives us an amplitude then of 3, and it's a bit easier to see. So let's start again. So we've got a period of 4 pi by using our formula 2 pi over n, n being a half. So key points will be up here at 3, because I've changed the amplitude to 3, at negative 3. Sorry, it's going to across the axis here at 2 pi, then here at negative 3, and at 4 pi. So our wave is going to look something like this, starting at the origin, through there and through there. Let's look at the negative part of the domain. Our domain here, by the way, is negative 2 pi is less than or equal to x is less than or equal to 2 pi. Okay, so that's our domain. So same thing on the other side. We're going to have a minimum there at negative pi. Pass through the axis there at negative 2 pi. Maximum here at 3 pi. Negative 3 pi and negative 4 pi. So the graph comes down through the origin, turning through, and turning. And that's our graph of y equals 3 sine 1/2 x. Next graph I'd like to look at is y equals 2 cosine 3x. It's the first time we've used the coefficient of 3 in front of the x. And it's a bit tricky. So let's use that formula we used last time, which is period equals 2 pi over n. Now n is the number in front of the x, so the period here, let's write it down here, period will equal 2 pi on 3. So in other words, one full wave will be over when we get to 2 pi on 3. It might be handy therefore to mark in some extra divisions here because the period is quite short. So I'm marking in some extra divisions. These divisions are actually pi on 6s. Okay, so that's neg pi on 6 there, for example, over here on this side, I'm about to mark in. Okay, so that's neg 2 pi on 6, neg 3 pi on 6, which is neg pi on 2. And, whoops, that wasn't a very good one. But you can see I'm marking in those divisions. It's going to help a little bit. I might just fix this one here up a little bit. A bit inaccurate. Okay, so we've got all our divisions marked in. Okay, and now we know that one full wave is going to finish at 2 pi on 3. By the way, the amplitude, because we've got 2 there, the amplitude is going to be 2. Okay, so let's mark in the key points. We're going to have one there, and then one at pi on 3 down here. Right, let's just do the first wave. So it's going to go up, it's going to turn at pi on 6, through pi on 3 to 2 pi on 3. So the same pattern will continue, like so. Not particularly well drawn. Let's just fix this one here up a bit. It's a bit hard here because it's such a narrow wave to get some good symmetry happening. But you can see here, let's fix this one up too. You can see here the pattern the graph does. It goes down there and back up to there. So that is the graph of y equals 2 cosine 3x, and the same pattern would repeat on the other side. I might just do it for the positive domain. So I've graphed that graph for the domain of 0 is less than or equal to x is less than or equal to 2 pi. Okay, could have done it a bit neater, but you get the idea. The key thing here is the period, okay, is 2 pi on 3. Why? Because n is 3, the number in front of the x, and the formula for period is 2 pi on n. Next graph I want to look at is y equals 2 cosine x, take 2. This is the first time we've had a shift, okay, and that minus 2 there is going to take the graph of 2 cos x down 2 places. Alright, so let's, I might just change colour here to red, and I'm going to start drawing in red the graph of y equals 2 cosine x. Okay, it's got a amplitude of 2, and we just mark in those key points. There they are, and draw in the cosine curve. Starts up here on the axis at 2, like so, down through there, up through there to there. That's the graph of y equals 2 cos x, and it repeats on the other side, of course. Mark in those key points, and our curve goes to there. Right, so that's the graph of y equals 2 cos x take 2. And we're going to change colour to blue, and we're now going to, because of the negative 2, we're going to shift the graph down 2 places. So I mark in the key points. So you notice there that point is now, it was originally there, take it 2 points down, it goes to there. So I'm taking all the points on my graph, those key points that I've talked about, on that wave, and taking them down 2 places. So there we go. Now it's a simple matter of drawing the curve, linking up those blue points, like so, and that's my graph of y equals 2x, sorry, y equals 2 cos x, take 2. Okay, next graph we're looking at here. Let's go back to my black pen. is going to be y equals 3 cosine theta minus pi on 3. I thought this, this time we might use, finding how to close the bracket there, I thought we might use theta this time, just to show you that it's not always y and x, that sometimes these can be y and theta. So I haven't been labelling them axes as we've been going, but if we were labelling our axes here, we'd have theta there and y up there. Should always remember to label your axes. I've been a bit slack not doing that. Okay, so what we're going to do is draw the graph of y equals 3 cos theta, and what we'll do after that, let's close that bracket if I can. There we go. What we're going to do after that is then take it or move it pi on 3 places to the right, because remember a negative pi on 3 in a bracket there with all our graphs does a right shift. Okay, so a horizontal shift pi on 3 places to the right. But first things first, and I'll draw it in red. We might just draw the graph of 3 cos theta. Okay, now the reason I've chosen some axes here that have got pi on 3s on them is that eventually we're going to have to shift this graph pi on 3 to the left. So it's just easier if I've got these divisions here of pi on 3, 2 pi on 3, etc. The only thing is though, I haven't got my pi on 2s marked in. So before we draw the graph, what I might do is just go through and mark in our divisions for the pi on 2s. So there's going to be one there, and also one there, and over on the other side there's going to be one here, and one here. So that's pi on 2 there, 3 pi on 2 there, negative pi on 2 here, and negative 3 pi on 2 over here. So, time to draw the graph of 3 cos theta. So, key points there, 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 and over here. So let's link those up. And on the other side as well. So, there's our graph of y equals 3 cos theta. Let's just write that in red over here. Now what we want to do, because of that negative pi on 3 over here, is transfer everything pi on 3 to the right. So I'm going to change pens to a blue pen, and I'm going to, with all the key points, I'm going to move them, and just put little crosses for the moment, pi on 3 places, so one division here, and that's why it's handy to have pi on 3 divisions, pi on 3 divisions to the right. So that one goes to there, that one goes to there, that one to there, that one to there, that one to there, and that one to there. So our graph now starts up here. Well, it actually doesn't. Whoops! It actually doesn't start up there, but it'll start a bit further down. But I'm going to mirror the existing red graph with this blue graph, like so. Okay, and of course the graph would turn here at negative 5 pi on 3 and move back to there. So the blue graph there is the graph that we want. It's the graph of y equals 3 cos theta minus pi on 3. Just wasted. Okay, the last graph I want to do here in this presentation is y equals cosine a half and in brackets we've got theta minus pi plus 1. Okay, so that's what I'd like to do here. Now, there's no change in amplitude because in front of the cos there is no number greater than 1. It's just 1, of course. So the amplitude will be 1. The half there is going to change the period. So let's calculate that. We did this in an earlier slide, but we'll do it again. Period equals 2 pi on n. N's the number there in front of the theta, or the bracket containing theta. So it's 2 pi on a half. 2 pi divided by a half is 4 pi. So a full wave will take 4 pi. we're going to get two shifts. We're going to get a shift of pi to the right, and then eventually we'll also shift the graph one place upwards. So let's have a look first up. So what I think I might just draw first is the simple graph of y equals cos half theta, and then we'll do the shifts after that. So it's got a period of 4 pi. So let's move that in a bit. So our key points are going to be here at pi, at 2 pi, at 3 pi and 4 pi. So the graph will look something like this, a way of going to there, and it will be the same on the other side. Just mark in my key points. Key point there. So down goes the graph, turning up to there and down to there. There's my graph. Alright, now this graph is going to be moved pi places to the right. So let's get a different colour happening here. Go for magenta. And I'm going to take all my points and these little magenta crosses, move them pi to the right. So that one's there, that one goes to there. So concentrate doing this. There we go. Alright, so then imagine the graph now looking something like this, and I'll start it. Just make sure I've done all my points the right way. I have, so here we go. The graph now looks something like this. And the same down here, like so. So the magenta graph there is the graph of, and I'll write it in magenta, y equals cos a half theta minus pi. Okay, now we have to allow for the plus 1. So the last thing we'll do, we'll change colour again. Change colour to a green one. We have to lift the whole graph up one place. So taking the key points now and lifting them up one place. Okay, so we've got one there. That one's 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 there. And finally, over here, okay, we've got that last one being up, up to there. Okay, so I've taken all my key points and shifted them up. So now the graph, if I draw the green one, let's make sure we've got everything under control here. So here we go. It's going to go there, up to there, through that, through that point, bottoming out there, through there, down through there to there. And that green graph will be the graph that we're after. There. So I hope you've enjoyed this presentation. A little bit of background on the easier forms of trig graphs, the dilations, shifts left and right, changes of amplitude, all that sort of thing. So see how we go. If you want to do some now from the book, what you could do is exercise 6D. Have a go at questions 1 through to 7. Sort of covers some of the questions we've done there on those slides. Good luck with it.